Hi friends, this is Sirisha, Assistant Professor in the Department of SNH, Chebrol Engineering College. In this video lecture, we are going to look at another bracketing method that can be used to find the root of the function, unlike bisection method we saw in the previous video lecture. So method of Regula false or Falsy position method. Consider an equation of the form B, f of x is equal to 0, where f of x is continuous function defined between a and b, such that f of a and f of b having opposite signs. Means first we select 2 points a and b such that f of a be positive and f of a b be negative, so that f of a into f of b less than 0. Hence, there exists a root lies between a and b. So, regular falsy method is based on the repeated applications of intermediate value property. Here, the graphical representation of this method, which is easily understandable. Let given f of x is continuous in the closed interval a comma b, such that f of a into f of b less than 0. That means there is a root lies between a and b for given f of x. So first of all, we search for the points a and b such that f of a and f of b have opposite signs, so that there will be a root of f of x is equal to 0 between a and b. Geometrically, these points are denoted a comma f of a and b comma f of b on the curve y is equal to f of x. This is the curve y is equal to f of x. Here the point a comma f of a in negative and b comma f of b is a positive point. If we draw a line joining these 2 points, that will be intersect in the x-axis, that is the exact root of the given equation. Thus, the equation of the curve joining these 2 points a comma f of a and b comma f of b is as follows: y minus f of a is equal to f of b minus f of a by b minus a into x minus a. This formula we can write it from the equation of the line joining 2 points a f of a, b f of b. Here a f of a is x1 y1 and b f of b is x2 y2. We know the formula y minus y1 by y2 minus y1 is equal to x minus x1 by x2 minus x1. From that formula we write this y minus f of a is equal to f of b minus f of a by b minus a into x minus a. Let it be equation 1. So this chord will meet the x-axis when y is equal to 0. So the chord meets the x-axis means y is equal to 0. The resulting x is the approximated for our desired root. Putting y is equal to 0 in equation 1 and rearranging all the terms, we have x is equal to a minus f of a by f of b minus f of a into b minus a. This is the formula for finding iterations of the given function using regular falsy method. This can be also simplifying like xi plus 1 is equal to a into f of b minus b into f of a by f of b minus f of a. This is the formula for finding approximations of given equation using regular false method. Steps to find solution. Let f of x is continuous in the closed interval a comma b for given f of x is equal to 0, such that f of a into f of b less than 0. For suppose the initial roots x0 and x1, we find the initial approximation x1 using the formula a f of b minus b f of a by f of b minus f of a. So we get some value for x1. We substitute this x1 value in given function. Check if f of x1 is equal to 0, then x1 is the root of f of x is equal to 0. If f of x1 not equal to 0, then the root lies between a and x1 according as f of x1 greater than 0 and f of x1 less than 0 respectively. We are assuming that if f of x1 less than 0, then the root lies between x1 and b, x1 and b. So the second approximation root of f of x is equal to 0 is x2. So x2 is equal to x1 into f of b minus b into f of x1 by f of b minus f of x1. We get the value for x2. We substitute x2 value in given equation. That equation, if f of x2 is equal to 0, then x2 is the root of f of x is equal to 0. Suppose f of x2 not equal to 0, then the root lies between a and x2 or x2 and b according as f of x2 greater than 0 and f of x2 less than 0 respectively. So this process should be continued until any two successive approximations are same or equal, which gives the required root of given equation. Merits and demerits of regular Falsi method. So merits, it is fast convergence method as compared to bisection method. So it gives fast convergence as when compared with bisection method, we get fast convergence using regular Falsi method. So no need to calculate the complicated derivatives of a function using this method. So demerits of regular Falsi method, it is very slow convergence method when compared with Newton-Raphson method. So the convergence is very slow when the function has a big curvature. So these are the merits and demerits of regular Falsi method. So from first bracketing method, bisection method and regular Falsi method, what is the difference means? The Falsi position method and bisection methods are quite similar. The only difference is the formula used to calculate the new estimate of the root. Okay. So first problem, using regular Falsi method, compute the real root of the equation x e power x minus 2 is equal to 0. Correct up to 3 decimal places. So again, using regular Falsi method, compute the real root of the equation x e power x minus 2 is equal to 0. Correct up to 3 decimal places. In given problem, the function is x e power x minus 2 is equal to 0. X e power x minus 2 is equal to 0. And also given carried out iterations up to 3 decimal places are equal. Up to 3 decimal places are equal. So in this problem, not mention the interval a comma b. So what we do first, here we select a and b such that f of a into f of b less than 0. So solution, let us consider f of x is equal to x e power x minus 2. By putting x is equal to 0, we get f of 0 is equal to minus 2. And by putting x is equal to 0.5 in the given equation, we get f of 0.5 is equal to 0.5 into e power 0.5 minus 2 is equal to minus 1.17. By putting x is equal to 1, in the given equation, we get f of 1 is equal to 0.718, which is negative. So that therefore the root lies between x is equal to 0.5 and x is equal to 1. As the value of f of x at x is equal to 0.5 is negative and at x is equal to 1.0 it is positive, therefore the root lies between x is equal to 0.5 and x is equal to 1. So the root of the given function x e power x minus 2 is lies between closed interval 0.5 comma 1. So first step, for x naught is equal to 0.5 and x1 is equal to 1, then the first approximation of the root is given as x2 is equal to x naught minus x1 minus x naught by f of x1 minus f of x naught into f of x naught. Here we substitute the values of x naught, f of x naught and x1 and f of x1. We get x2 is equal to 0.8098. Now we substitute x2 value in given function. We get the value minus 0.18, which is negative. So here at 0.8098 the value of f of x is negative. Here 0.8098 is replaced the negative root, that is 0.5 for next iteration. So in second step, root lies between x2 is equal to 0.8098, this is negative root, and x1 is equal to 1, positive root will be remains constant. So therefore the root lies between 0.8098 and 1, and let x1 is equal to 1 and x2 is equal to 0.8098 for next approximation. The formula is x3 is equal to x2 minus x1 minus x2 by f of x1 minus f of x2 into f of x2. So we substitute the values of x2 comma f of x2 and x1 comma f of x1. We get x3 is equal to 0.8479. Now we substitute x3 value in given equation. We get f of x3 is equal to minus 0.02, which is negative. Here at 0.8479 the value of f of x is negative. So here 0.8479 is replaced the negative root, that is x3 is equal to 0.847 and x1 is equal to 1 be the roots of the next iteration. So the formula for next iteration is x4 is equal to x3 minus x1 minus x3 by f of x1 minus f of x3 into f of x3. Substitute the values of x3, f of x3 and x1, f of x1. We get x4 is equal to 0.8519. Now we substitute x4 value in given function. We get f of x4 is equal to minus 0.0031, which is negative. Here at 0.8519 the value of f of x is negative. So here 0.8519 is replaced the negative root, that is 0.8479. So therefore the root lies between 0.8519 and 1 for the next iteration. For next approximation, the value of x is in between 0.8519 and 1. So the approximation x5 is equal to x4 minus x1 minus x4 by f of x1 minus f of x4 into f of x4. We substitute x4 and f of x4, x1 and f of x1 values. We get x5 value is 0.8525. Some from fourth and fifth approximations, we conclude that x is equal to 0.8525. So here in fourth approximation, the value for x is 0.8519. So we can correct up to 3 decimals. This value will be equal to 0.852. So here in fifth approximation, the root will be 0.852. So from fourth and fifth approximation, we concluded that x is equal to 0.8525 be the approximate root, correct up to the 3 decimal places. Correct to the 3 decimal places. Coming to next problem, find the equation x cube minus 5x minus 7 is equal to 0, which lies between 2 and 3 by the method of false position. So in this problem, they mention the root of the given function lies in 2 and 3. Okay. So solution. So let us consider given function be f of x. So f of x is equal to x cube minus 5x minus 7 is equal to 0. By putting 2 in given equation, we get the value f of 2 is equal to minus 9, and by putting x is equal to 3 in given function, we get the value 5. So here 2 is the negative root and 3 be the positive root. Hence the root lies between 2 and 3. So for first approximation, then the first approximation of the root is given as x2 is equal to x0 minus x1 minus x0 by f of x1 minus f of x0 into f of x0. So we substitute the values x0 and f of x0 and x1 and f of x1. We get x2 is equal to 2.64286. So and also find f of x2. We get f of x2 is equal to minus 0.7547, which is negative root. Here at 2.64286, the value of f of x is negative. So here 2.64286 is replaced the negative root 2, that is 2. So therefore the root lies between 2.64286 and 3. So for next iteration, x2 is equal to 2.64286 and x1 is equal to 3. So that the approximation, the formula for approximation x3 is equal to x2 minus x1 minus x2 by f of x1 minus f of x2 into f of x2. Substitute the values of x2 2.46286 minus x1 3 minus x2 2.64286 by 5 minus 1.7547 into f of x2. F of x2 value is minus 0.7547. We substituting these values, we get x3 is equal to 2.73564. We substitute this value, this x3 value in given function, we get f of x3 is equal to minus 0.2054, which is negative. So here at 2.73564, the value of f of x is negative. So here 2.73564 is replaced the negative root, that is the root for next iteration, root lies between x3 is equal to 2.73564 and x1 is equal to 3. and x1 is equal to 3. So the formula is x4 is equal to x3 minus x1 minus x3 by f of x1 minus f of x3 into f of x3. Substitute the values of x3 f of x3, x1 f of x1. We get x4 is equal to minus 0. x4 is equal to 2.7461. So and also find f of x4, we get f of x4 is equal to minus 0.0219, which is negative. So here at 2.7461 the value of f of x is negative. So here 2.7461 is replaced the negative root, that is for next iteration take the root lies between x4 is equal to 2.7461 and 3. So for next iteration the formula is x5 is equal to x4 minus x1 minus x4 by f of x1 minus f of x4 into f of x4. We substitute those values in this formula. We get the x5 value 2.7472 and also find f of x5 value. We get f of x5 is equal to minus 0.00258, which is negative. So here at 2.7472 the value of f of x is negative. So here 2.7472 is replaced the negative root 2.7461 for next iteration. So hence again root lies between 2.7472 and 3. So the formula for next iteration is x6 is equal to x5 minus x1 minus x5 by f of x1 minus f of x5 into f of xy. We substitute the values x1 comma f of x1 and x5 comma f of x5. We get x6 is equal to 2.7473. So we observe that from 5th and 6th approximations we concluded that x is equal to 2.7473 be the required root. So here at x5 the value is 2.7472 and at x6 the value is 2.7473. So the x value be the, from 5th and 6th approximations we concluded that x is equal to 2.7473 be the required root up to 4 decimal places. This is the procedure to solve problems in regular Falsi method. Thank you.